Okay, so section 2.2 is trig ratios of any angle. And in this section, we're going to be talking about a point xy on the Cartesian plane. And what we're going to be looking for is being able to solve the value of sine of theta, cosine of theta, tangent of theta given any point on some kind of terminal arm. So we're looking at these types of pictures right here. I already circled this one right here. A and B, these two guys right here. And basically, if you're given some kind of point, so right here I'm highlighting x, y, and b, you can see that what we're going to do is we're going to try to find what this angle would be. Okay, some of the times we're going to be looking for this angle. Sometimes we're going to be looking for the value of x, y, and r, okay, depending on what we're given. Okay, we're going to do that using, sometimes we're going to be using special triangles, and we're going to be using our reference angles and our knowledge of sine, cos, and tangent. So we know that sine is opposite over hypotenuse, right here. We know that cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. In relation to a diagram, okay, so we're looking down here. With relation to a diagram, what that means is if you're given a point, x, y, just suppose this dotted line right here, okay, by y is not there. You're just given this angle right here. R is the hypotenuse of an imaginary triangle. That's when you extend this line to the x-axis and you get a right angle here, so now you have a right triangle. Cosine, for instance, actually we'll start with sine. Sine, for instance, is y is opposite, right, opposite, which is y, over r. That's where this comes from, y over r. Cosine is x over r, right, because it's adjacent over hypotenuse, and tangent is y over x. That's where these come from. You're going to have to commit this to memory, okay? Commit these relationships to memory. So, looks like a confusing slide, but the x and y values, so these values over here of x and y, will actually, the sign of them changes depending on what quadrant they're in. Okay, in quadrant 1 right here, that's right here at quadrant 1, everything is positive, right? When you move over to quadrant 2, over here, you can see that x is negative, y is still positive, right, because we're still in the positive direction. R is always positive. Always positive. Quadrant 3, x is still negative, but now y is negative. So here basically everything is negative except r. R is never negative because it's a distance. Finally, in quadrant 4, we have x is now positive, right, because it's over here, but of course y is negative. Okay? R is always positive, right? R is always positive. That's important. So, let us continue on. This is summarized by something called the cast rule, okay? The cast principle. And this is just a flat-out synonym, or sorry, acronym to remember this. You start over here, okay? That's C for cosine is positive. All is positive here, or all are positive, sorry. Sine is positive over here, and tangent is positive in quadrant 3. Little way you start like that, okay? Work yourself counterclockwise. Okay, so looking at example 1, the solutions in your notes, let's do a practice problem associated with that example. And the title of this is essentially write the trig ratios for angles in any quadrant. Very applicable. The point -5 and 12 lies on the terminal arm of an angle in standard position. Determine the exact trigonometric ratios for sine, cos, and tangent. Okay. First of all, let's draw it. There's our x and y axes. The point -5 and 12. So clearly -5 is somewhere around here. 12 is somewhere down in quadrant 3. So let's just say that's what we're dealing with. Okay. And that angle is this right here. We're looking to determine all the values of x, y, and r. Okay. We know that this point right here is -5 and -12. Okay. So what can we do from that? X is -5, y is -12, so we need to find r. We're going to find this using Pythagoras. Okay, so when you extend this triangle, right, what this basically says is that the y is -12, x is -5. We're looking for this value right here. Okay, that value right there, which is r. This is r. So, what will r be? Well, we have to solve. It's going to be square root 5 squared plus 144. Okay, 12 squared, let's do that. So 25 plus 144. And all of this square rooted comes out to be 13. It's positive 13 because r is always positive. So now once you have the three values, you have to know that sine of theta is y over r, which is simply -12 over 13. Okay. Cosine of theta is equal to x over r, which will equal -5 over 13. And tangent of theta, what's that equal to? Y over x, and that is equal to -12 over -5, which the negatives cancel to give you 12 over 5. And there you go. Those are your three solutions. And that wraps up practice 1. Looking at the next type of question we're going to be given here, that will be talking about an exact value, determine the exact value of a trigonometric ratio. Very useful. Okay, for instance, cosine of 135. You can see the solution here using a special triangle. I'm going to simply do this quite directly. Our next question is sine of 240. Okay, sine of 240. I'm going to draw it. Need to focus on my drawing here. 270 is right here. Okay, this quadrantal angle, right? It goes 90, 180, 270. So 240 is somewhere there. And that angle is 240 degrees. So what we're actually interested in is we're going to be interested in the reference angle. Okay, because sine of theta is equal to opposite over hypotenuse. Okay, you're going to see why this makes sense. We're going to use a special triangle here. And actually maybe I'll do this in green. And we'll extend this. Okay, what is this angle? That angle will simply be 240 minus 180, which will come out to be 60 degrees. Okay, we know that this is 60 degrees. So this is actually going to be, therefore, right, if we extend this, that's 90 degrees, so this is 30. So this actually is a 60, 30, 90 special triangle. The value adjacent to the 30 degree is root 3, right? Therefore this is 2, and then this r will be will be, oh, sorry, actually, that 2 should be a 1. Let's see how much this is. Perfect. Get rid of that. Should be a 1, and then this is actually a 2. Okay, that's special triangles from section 2.1. So, since sine is opposite of our hypotenuse, that means sine, okay, of, in this case, it will be 240 degrees, is going to equal opposite hypotenuse of this special triangle. Now, we're going to be keeping in mind our sines. This is actually going to be negative root 3, and this is going to be negative 1 because we're in quadrant 3. Now, quadrant 3, both x and y are negative, so opposite the angle here is now going to be negative root 3, and r is always positive. Take out a calculator, type this in. Type in sine of 240. What you're going to get, I'll do it right now, sine of 240. If you're in degrees mode, you're going to get negative 0.8660 ... Okay, a non-exact value in your calculator. If you figure out the decimal of this, so if you go negative root 3 over 2, it'll give you the exact same thing. But we want the exact value. We want this right here. Okay. So, our next example, and we'll do one more on this video, in part 1 of 2.2, is determining trigonometric ratios. Okay, determining trigonometric ratios. So, suppose theta is an angle in standard position with terminal arm in quadrant 3, and tangent theta is 1 over 5. Determine the exact values of sine and cos. What I would always do here is draw the situation. Okay. We have a terminal arm in quadrant 3. We know tangent is 1 over 5. Now tangent is equal to x over y. I apologize, sorry, y over x. Right, that's what tangent is equal to. But since we're in quadrant 3, we know that y is negative, and so is x. They're both negative values. Therefore, y has to equal negative 1, and x would have to equal negative 5. Okay, that gives you the positive value here. So, we're looking for the exact values of sine and cosine. So, how do we do that? Well, sine is y over r, and notice how we don't know r. Okay, and cosine is, of course, x over r. Well, you can easily find what r is simply by using our lovely Pythagoras theorem, which will be negative 5 squared plus negative 1 squared, all square rooted, to give you a lovely and slightly awkward solution of root 26, right? Square root 26. Now, we actually have the solution. Sine of y over r. So for sine, the exact value of sine here will be negative 1 over root 26. And the exact value for x will, of course, have to be negative 5 over root 26. And you can see in the previous slide, okay, expect awkward answers depending on what you get for y, r, or x. Okay, but trust your instincts and you should be fine. So that is it for the first video. On the second video, we're going to go over solving for an angle given its exact sine, cosine, or tangent value, and an approximate question using non-exact values. Okay, non-exact values. So check out the next one.